This is section 5.3, adding and subtracting polynomials. This may be the easiest section in the entire course. The hardest part, the definitions, which we have to get through, but then after that, the problems are pretty easy. First of all, definition of a polynomial. It's a term or a finite sum of terms in which all variables have whole number exponents and no variables appear in denominators or under radicals. So an example of a polynomial okay, 7x squared minus 2x plus 3. Now I know it says sum here, but remember I can always write a minus as plus and negative, so it still is a sum. Okay, the prefix poly means many. The base nomial means names or terms. So polynomial is literally many terms. Okay, now you're going to be talking about a lot how many terms a polynomial has. Terms are separated by a plus or a minus. So 7x squared is a term. 2x is a term. 3 is a term. Okay? The degree of a polynomial is the largest exponent that appears in expanded form, not factored, and that will make more sense later. Okay? So this problem right here, the largest exponent that appears is a 2. So this would have degree 2. Now I know that seems weird, but this actually will help you out a whole lot when we get to solving equations with these things. Okay? All polynomials must be written in descending power order. That means you write that term with the largest exponent first and then the second largest and so on. So basically, if this were my polynomial, it would not be proper to write negative 2x plus 7x squared plus 3. Numerically, it's the same, but it's not in the proper order. Your largest exponent needs to come first. Okay? We have special names for certain polynomials. A monomial, mono means one, is a polynomial with only one term. For example, 3x to the 7th. A binomial, and bi means 2, is a polynomial with two terms. So 3x to the 7th plus 4x cubed. A trinomial is a polynomial with three terms, tri meaning 3. So an example would be 3x to the 7th plus 4x cubed plus 2. The degree of all of these is 7, because that's the largest exponent that appears in any of these. Now after a trinomial, we don't have special names for them. Okay? So those are our vocabulary. Now let's talk about adding polynomials. It's simply combine like terms. That's it. Now, so far in the course, we have only dealt with terms like 3x plus 4x, where we didn't have a visible exponent on our variable. So we just had to look to see that they had the same variable. But to be a like term, it means a little bit more. You not only have to have the same variable, but you also have to have the same exponents on those variables. So for example, right here, the reason we wrote it like this instead of adding the numbers in front is that none of these are like terms. This has an exponent of 7, this has an exponent of 3. Even though they're both x's, these are not like terms. Okay? So let's look at 8r to the 5th minus 2r to the 5th. All we do is we add or subtract the numbers in front. 8 minus 2, that's 6. And then we have r to the 5th. Okay, that's it. 8 minus 2 is 6, and we keep the r to the 5th. That's our answer. It's simply combining like terms. You can almost ask yourself, okay, if these were both gone, noticing that they're the same. If they're both gone, what would I do? I would subtract it, I have 6r. You just keep the variable. Okay. So let's look at this one. Y squared minus 7y, or plus 7y minus 4y squared. We're looking for like terms, and I have squares here and here. This one does not have anything to match up with it. When you go to find your like terms, when you go to combine them, you really want to start with your largest variable. That way, when you're doing it, you're putting them in the correct order as you go along. Okay? Now, the coefficient on this y squared is a 1. So what I have is 1 minus 4, which will give me the negative 3, and then I keep the y squared, And since there's nothing to combine with this one, it just comes down. It's 7y. Okay, now let's try this one. We have more like terms. All right, I have 2x cubed. Do I have another x cubed? Yes, right here. Okay, and then I have an x squared, and I have another x squared. I'm matching those up, and then the x is going to be by itself. Notice how I'm underlining things as I go along. That's really going to help you because eventually we're going to have really long things that we have to combine and simplify, and it's very easy to think you've dealt with everything, but you haven't. So if you underline things as you're using them, you're less likely to miss something, okay? One thing that you don't want to do, and it's not for me, it's for other instructors. I know that other instructors will get angry if you mark them out like that as you use them, because for some people, this means you're canceling out and you're not really. So don't put a line through it just so you don't make another teacher angry. Just underline it, circle it, something like that. Okay, so I want to start with my largest exponents, which are 3's. So I have 2x cubed minus, that's a 1x. So that gives me 1x cubed, and we normally don't write the 1 because mathematicians are lazy. Okay, now add your square terms. 3x squared plus 5x squared is going to be 8x squared. And then we have to remember to bring down the minus 4x. And that's your answer. Okay, now sometimes you're going to end up with a problem written vertically. You can always take a horizontal problem and write it vertically. You can always take a vertical problem and write it horizontally. It's up to you. The nice thing about this is that you can line up your like terms, so it's just simply adding up and down. You do need to double check that your like terms are lined up, and you also want to pay attention to this word because you're going to have subtraction problems written that look pretty much the same. You might have multiplication that looks pretty much the same. We can't put a sign over here. A plus, you might think that just means it's a positive 9 instead of adding the whole thing. If I put a minus, you might just think it's a minus 9 instead of the whole thing. And if you put an x, you're going to read, if it's multiplication, you're going to read it as a variable, which would mess you up as well. Okay, so everything's lined up here. Let's go for it. Minus 6y cubed, 9y cubed. So I add these together. 9 minus 6 is 3, and I keep the y cubed. Okay. 8 plus 4 is 12, y. And then I have 5 minus 6, which is a negative 1. So your answer would be 3y cubed plus 12y minus 1. Okay, one more. Now the parentheses here, since we're adding, the parentheses don't really matter. They are written here so that you can see you're adding two different polynomials. And each of these polynomials is written in descending power order. But because it's a plus sign, and technically if you're distributing anything at all, it would be a 1, we can just ignore the parentheses. So let's look for our largest exponent, which would be the 4, and I don't have another 4. So I'm going to write down the 2x to the 4th. Okay, my next largest exponent is the 3, and I don't have another cube, so I have plus x cubed. Now I do have x squared terms that I can combine. It's going to give me 3x squared. And then I have my constants that I can combine, -1, +3. And that will give me a +2. So that should be your answer to this addition problem. We'll cover subtraction in the next part.